By the time we get into the period of 1880s to the 1920s, which I've described as the rise of corporate capitalism, the educational model has won out. The big story during this period is twofold. One is that capitalism itself, capital industries, have become increasingly scientific. The research and development activities supported by new patent laws are well underway. And engineers find themselves working primarily, almost completely, as salaried professionals. The corporations employ engineers on many occasions to support industrial research. And here we find a new American-style approach to research. In contrast with the French, who are still very much mathematically based, the United States develops a very elaborate system of industrial research. And I'll quote from Kranakis to help you understand how this developed. Quote, "On the industrial research side, the situation was entirely different than in mathematical theory, in which the United States made almost no contributions. In the United States, dozens of firms and institutions began to carry out industrial research and testing on a more or less consistent basis during the 19th century. Chemical companies like Dow, DuPont, Kodak, railroad companies and steel companies like the Pennsylvania Railroad and Carnegie Steel, companies involved in mechanical or electrical engineering like the Sellers Company, and other electric companies. The proprietor of Locks and Canals in Lowell, Massachusetts, which was selling hydraulic turbines. Sperry Gyroscope, Edison Electric, the Edison companies, Bell Telephone, government bodies like the Army, Navy, the National Bureau of Standards, and private institutions and professional societies such as the Franklin Institute. Considered overall, American industrial research was remarkable for its thoroughness, precision, and creative character, and became the basis for technological innovations of international importance in every imaginable field." So, tremendous expansion. We don't want to overstate the point that the French were expert in the sciences. Rather, their focus was on math-based sciences. And in the United States, the emphasis here is more on empirically derived insight, empirical scientific work. The increasing importance of new sciences in engineering led to the appearance and development of two new fields of engineering, namely electrical and chemical engineering. As Noble puts it, since neither the electrical nor the chemical engineers had any traditional cultures to contend with, the brand of professionalism which defined the engineer in terms of his position within the corporate hierarchy and his scientific training became the predominant one. So chemical and electrical and chemical engineers took for granted that they were going to be working inside of big companies, in contrast with the early mechanical engineers and indeed the civil engineers. Noble also writes, continuing, quote, "Electrical engineering, as the product of both mechanical engineering and physics, was firmly rooted in science from the outset. There was no formidable rule of thumb tradition as in mechanical engineering, and so scientific training readily became a mark of professional identity. Note here, then, electrical engineering grows out of, is a descendant, a family descendant of mechanical engineering. You basically take mechanical engineering, you throw in a little physics, and you've got electrical engineering." Calvert supports the same point regarding the shop culture, or the absence of a shop culture tradition. Quote, "The absence of a shop, field, or mine culture in electrical engineering freed that field of the often bitter controversy between shop and school, or theory and practice." So the electrical engineers, with their direct link to science and to new companies, splits off from the American Society for Mechanical Engineers to form their own society, what was then the AIEE. Mobility for these engineers was open, but entirely within the rapidly expanding corporations. As Charles Steinmetz, head of General Electric, pointed out, quote, A very large percentage of the prominent electrical engineers were associated with large manufacturing or large operating companies. End quote. And so the majority of electrical engineering graduates were absorbed into the large corporations, especially General Electric, a descendant of the Edison companies, and Westinghouse. So the majority of the members in the AIEE were salaried professionals. The same was true in chemical engineering, which followed on the heels, an industry that followed on the heels of the electric power industry. With chemical engineering being basically a descendant of mechanical engineering through a union with the science. Chemical engineering, the product of combining mechanical engineering with chemistry. It was created, according to Calvert, to meet the demands of the expanding chemical and chemical process industries. The key step in separating chemical engineering from chemistry, as historian Terry Reynolds has pointed out, lay in the engineering concept of unit operations, the division of chemical processes into qualitatively distinct units. So we find in the early part of the 20th century this rapid expansion of interest in engineering education. Indeed, the first decade of the 20th century saw engineering education in America reach the height of its popularity in relation to other divisions of higher education, as the number of engineering students increased from say 10,000 per year, or sorry, the total number of students, 10,000 to 30,000 in the period 1890 to 1910. As engineering education then became more scientific, the companies began to accept the job of practical training. In 1930, looking back, author of the Wickenden report, Wickenden, wrote or observed, quote, "This increasing scientific emphasis was greatly advanced by the close bond between the schools and the newer industries, which had developed directly out of scientific research and technique, notably the electric industry. An understanding arose almost from the beginnings of the new industry, under which the employers assumed practically the entire responsibility for the practical training of the student, and the college was left to devote itself to the scientific foundations."